Hello, my dear students. This is Ikhlaq Sir Physics. So, my dear students, today we are going to discuss one more problem from the electrostatics, as we are in love with the electrostatics. Okay. So, and this question has been asked in the JEE 2024. Okay. Now, what the question is exactly is like this. This here a line charge. Okay, whose charge density is given that's equal to plus lambda. It's a positively charged wire. Okay, then a negatively charged particle is there minus q. Obviously they will attract each other. Now because of the force of attraction, this negatively charged particle is going to revolve around this wire in a circular path. All right, and what we have to calculate is the time period. Okay, now first and foremost how we can calculate the time period. तो सबसे पहले आपको ये पता होना चाहिए ये time period होता क्या है. It's simply the time taken by the charged particle to complete one circle. Now when the charged particle completes one circle, the distance covered by the charged particle will be obviously circumference, which is 2 pi r, and the speed of the particle is equal to v. So that means the time period will be equal to the circumference divided by the speed. Okay, so from that we have to calculate speed. Now how can we calculate the speed? We can calculate the speed if we know which force is there which is responsible for the charged particle to move in a circular path, or which force is there which will provide the necessary centripetal force. Of course, there is a force, and that force is called electrostatic force. Can we calculate the electrostatic force? Yes, we can. How can we calculate the electrostatic force? If we know the electrostatic field. So the starting point is like this. I'll write down what's the electrostatic field due to the line charge. Okay, so this is the electrostatic field due to the line charge. That's like this. That's like this. Electric field equals to 2 into k into lambda divided by r. This is the electrostatic field. All right. Okay, where lambda is the charge density, k is electrostatic constant, r is the distance. All right. The next what I can do is this: the force on the charged particle. I will calculate that. That comes out to be q multiplied by e. So what is that exactly equal to? That's twice k lambda into q divided by r. This is the electrostatic force. Now see that this electrostatic force, it is directed towards the center. This electrostatic force, when it is directed toward the center, so that it satisfies the condition for behaving as a centripetal force. Hence it behaves as a centripetal force. And what's the expression for the centripetal force? You know that that's mv square divided by r. That's what I am going to write is this, that it will provide the necessary centripetal force. So what I will write down is this twice k lambda into q divided by r equals to centripetal force, and you know the equation for that is mv square divided by r. Okay, now this r and this r is going to cancel. From there what I can calculate is the velocity of the electron. Let me write down the velocity of the electron. What is that equal to? Not the electron but the negatively charged particle. Root of twice k lambda into q divided by what? Divided by m. This is the orbital velocity of the electron. Okay, this is the orbital velocity of the electron. Orbital velocity means the velocity with which the charged particle it is orbiting around the line charge. All right, but we are supposed to calculate the time period. Now what's time period? The time taken by the charged particle to complete one full circle. This is what I will write. Time period is equal to the circumference, which is equal to 2 pi r, and the speed divided by orbital speed, which is v naught. We have calculated orbital velocity. Let's put it here. So time period will be equal to twice pi r divided by, what's the orbital velocity equal to? That's equal to root of 2k lambda into q divided by what? Divided by m. We are done with the time period. This is the time period of the charged particle. Okay, and this question has been asked in the JEE 2024. In the next session we'll be back with one more problem in physics. Okay, so see you then.